Today we're going to talk about complex numbers and roots, section 5.5. So continuing on with some quadratics, we're talking about now some complex numbers and roots. So we're going to add to our number system today. Complex numbers and roots, section 5.5. First thing we're going to talk about is an imaginary unit. Up till this point, all the numbers you have learned so far have been real numbers. And that changes today because today we're now going to introduce the imaginary unit. For example, let's say I gave you the problem, the square root of 1. We all know the square root of 1. Square root of 1 is? 1. Okay, square root of 1 is 1. Now, what does a square root really mean? A number multiplied by itself, right? So, for example, 1 times 1 is 1. Well, we get problems like this that are now the square root of negative 1. Well, what's the square root of negative 1? A lot of times, oftentimes, people say negative 1. However, negative 1 times negative 1 is actually positive 1. Okay? So what happens here when you get the square root of a negative is that's an imaginary unit, or the letter I. The square root of negative 1 is I. Okay? So now we're going to use that to get imaginary numbers. For example, let's say I have the square root of negative 16. Well, I can break that down as the square root of 16 and the square root of negative 1. Square root of 16 is 4. The square root of a negative 1 is actually I, so my answer there is going to be 4I. Okay, so we're taking these same ideas and we're introducing now the unit I. A complex number. A complex number is a number that can be written as the form A plus BI. Basically, it's going to have a real part and it's going to have an imaginary part. Okay, where A and B are real numbers and I equals negative 1. And here are examples of that. 4 plus 2I, 5 plus 0I, 0 minus 7I. All of those are examples of complex numbers. And then again, I have my real part, and then I have the imaginary part. Real part is the real number. Imaginary part has the I in that part. Okay, when we think of I, for example, we're going to do some like combining like terms and such later on. I is just like an X. You can think of it as an X, so like you can't combine terms there, right? It's different terms. Okay. And then lastly, we're going to talk about complex conjugate. A complex conjugate is of any complex number, A plus BI. It's now going to be A minus BI. Okay? So somebody earlier is like, well, it's like the opposite. No, because the opposite would technically be negative 4 plus 3I. But what is opposite is my imaginary part. So I'm switching these signs in my imaginary part. Okay, that's the complex conjugate. So look here. This represents the numbers that we know. For example, what is the smallest subset of numbers that we know? Natural numbers. So this smallest inside box, that's the natural numbers right there. After natural numbers came the whole numbers. After whole numbers came the integers. After integers was the rational. Next to rational numbers, we had the irrational. And then those made up the numbers that are real. And now today we're going to introduce what is the, which one starts with an I? Imaginary. So I have the imaginary numbers, and all of this together makes up what's called the complex numbers. So that's kind of a subset of what this looks like. So is there a way that could be real and imaginary? No, we can't be real and imaginary. Does everybody notice that? See how this line divides? Okay, imaginary number is separate from a real number. Just like a rational number is separate from a rational number, okay, imaginary number is separate. So there are some examples of all that. Now let's put this into practice here. Here's what we're going to be doing. We're going to be simplifying some radicals. For example, I have the square root of negative 25. Well, we know we can break this down as 25 times negative 1. What's the square root of 25? 5. What's the square root of a negative 1? So my answer there is going to be 5i. Okay, so we're breaking down the radical like we have been doing, and now we're just going to include the imaginary part. Again, I can do this with a tougher problem, like we had the square root of negative 48 here. Or negative square root of negative 48. I can break down 48 as 48 times negative 1. Then we broke down 48. That's part of our warm-up problem there. 48 breaks down as 16 and 3. What's the square root of 16? 4. So I pull that out. Square root of negative 1 is I. So I have negative 4i square root of 3. Okay, so we're going to be breaking down the numbers just like we already have been doing. So let's look at number 1 here. I want to express each number in terms of I. I have the square root of negative 72. So 72, what's the perfect square that goes into 72? It's up there. 36, 2 and negative 1, right? What's the square root of 36? 6. What's the square root of negative 1? And then can 2 break down? Nope, so that's going to stay inside. So it's 6i square root of 2. And there's your answer. 2. I have 4 square root of negative 45. I want to break down the square root of negative 45. Well, perfect square that goes into 45 is 9, 5, and then I have negative 1. What's the square root of 9? 3. So take 3 times 4 and I get 12. What's the square root of negative 1? I. And then square root of 5 can't break down, so it's going to stay inside. 12i square root of 5.
Wait, so you multiply?
Number 3, square root of negative 100. Well, what's the square root of 100? 10. Square root of negative is? No. So I really have the square root of 100. Oops, not. Yeah. And the square root of negative 1. What's the square root of 100? 10. What's the square root of negative 1? So I get 10i. 5. It means I.
No, I know, but you know when you did a negative 100, but then you did the square root of 100?
I did the square root of 100 times the square root of negative 1. I just kind of broke it down to the 2 parts.
Oh, yeah.
Yep.
So you can do that. Just make it nice.
Yep. So 4. 5 times the square root of negative 54. Well, what's the perfect square that goes into negative 54? What'd you say? 9 and 6. So I'm going to say negative 9 just to make that simple here. So I have the square root of negative 9 and square root of 6. What's the square root of negative 9? Remember, square root of negative is I. So I'm going to get 3i. So I have 3i. I take 3i times 5, and that gets me 15i square root of 6. Remember, square root of a negative is not a negative. Square root of a negative is I. 5. Square root of negative 64. What's the square root of negative 64? Somebody said it. 8. So square root of a negative is? So I get 8i. Now I take 8i times 2 and I get 16i. Because I didn't multiply them.
Yeah, but then don't you break down like that? So 8 and 6 can go into 64. So would you break down the 6 or no?
Now number 6, a little bit tougher here. 98. Does anybody know the perfect square that goes into 98? Think about it here. There is a perfect square that goes into 98. 47 is not perfect square. 49. Yeah, I could break it down as negative 49. And what 49 times what is 98? 2. So it's really negative 49 and 2. What's the square root of negative 49? 7i. So I take that 7i and bring it out front. I get negative 7i square root of 2. And I break that down. Nice job. Next part we're going to talk about is the complex conjugate. Okay? Remember, complex conjugate would be like if I had, A plus BI. Gosh. The complex conjugate would be A minus BI. Okay? So notice the imaginary part is different. So if I have negative 9i, what's the complex conjugate of that going to be? Positive 9i. Okay? Number 8, I have 1 plus 4i. What's the complex conjugate of that? 1 minus 4i. Good. In 9, I have 12 minus I. What's the complex conjugate of that going to be? Anybody? 12 plus I. Good work. Okay, so complex conjugate means the opposite of the imaginary part there. Good work. And lastly, what's this lead to? Well, now we're going to start solving some equations with this. Yesterday we had problems that were something like this, like x squared. X squared equals 25. Okay, we had a problem like that yesterday. And remember, what's the opposite of a squared term? Square root, right? So I take the square root, what's square root of 25? So we'd say, hey, our answer was yesterday, x equals plus or minus 5. That's what we did yesterday. Today now, we're going to get problems like this. X squared equals negative 64. Well, same idea. What's the opposite of a squared term? Square root. So I take the square root of negative 64. What's the square root of negative 64 now? So I have x equals plus or minus 8i. Okay? So that shows you how it works. So let's try number 10 here. I have x squared plus 18 equals 0. I need to solve for x. So in order to solve for x, I need to get x alone here. What would I do with 18? Subtract it to the other side. So I have x squared equals negative 18. What undoes a squared term? Square root. So I do the square root of negative 18. Well, 18 breaks down as 9, 2, and negative 1. What's the square root of 9? So I have x equals plus or minus 3. What's the square root of negative 1? I. Then I tack on the square root of 2.
Tristan Hughes, Colin Watsky, please come to the office. Tristan Hughes, Colin Watsky, please come to the office.
So yeah, I get x equals plus or minus 3i square root of 2. 11, same idea here. I need to get x alone. So notice I subtracted 24 on both sides. So I get 6x squared equals negative 24. Then I need to divide both sides by what? So I divide both sides by 6. And that gets me x squared equals negative 4. What's the opposite of a squared term? What's the opposite of a squared term? Square root. So I do the square root here. What's the square root of negative 4 going to give me? Square root of a negative is I. So I get plus or minus 2i. Again, you have to remember, square root of a negative is not a negative. It's going to give me I, the imaginary part. 12, I need to work this out. Jake, what am I going to do first? So I subtract 49. X squared equals negative 49. What do I do next, Jake? Jake, what's the square root of negative 49 going to give me?
7 plus or minus 7.
Yep, and I need to make sure I include that plus or minus out front. So x equals plus or minus 7i. Good job. Take a couple seconds, try these 3 on your own. All right, number 13. Katie, walk me through it. What'd you do first? So we minus 100. So I get x squared equals negative 100. And you get for an answer x equals plus or minus 10i. Nice job. 14. 3x squared plus 108 equals 0. Walk me through it. King, what'd you do?
Subtracted
Ooh. Slow down there, Speed Racer. So you have 3x squared equals negative 108.
Okay, you guys be on the court.
Divide by 3. So I guess it's x squared equals negative 36. You take the square root, and then what'd you get for an answer?
X equals
Plus or minus 6i. And 15, what did I do for 15? Dennis, what'd you do?
Minus 12 over.
So minus the 12.
Squared 6.
So x squared equals negative 12.
Yeah.
Then-
That's where both of them. And I want to say, is 6 the highest number to go into?
6 is not a perfect square.
Is it
Isn't so
zero
the 4
to
then?
I?
It'd be 4.
Okay. I put 4i the first time, but yeah.
So it's not going to be 4i, because what it breaks down is 4 and 3.
Oh, 4 and 3.
But what's the square root of 4?
2.
So I have plus or minus 2i square root of 3.
Hey, I got that right after.
There it is.
Is it when 6 go into 12?
But 6 is not a perfect square. Remember? Because what's the square root of 6?
Yeah.
We know square root of 4 is 2, right?
Yeah, okay.
Yep. Here's your assignment.